In the previous question, wherein we had been given a triangle whose vertices were -4 and 2, 6 and 4, 2 and -2, we were supposed to find the equation of the median that we have found, the equation of the altitude BM that also we had found. Now he wanted us to find the equation of the right bisector of AB. Now for that we will draw this triangle again for our understanding. So the triangle is like this, where A is having the coordinates 4 and 2, B is having the coordinates 6 and 4, and C the coordinates were 2 and -2. Now he is saying that we have to find the equation of the right bisector of AB. What do we mean by the right bisector? The right bisector means a line which will divide this AB into two equal parts and as well as is perpendicular on AB. Now it's not necessary that this line will pass through C, right? Unless it's an equilateral triangle. So it may be like this also. If it is an equilateral triangle, then the right bisector will definitely pass through the point, the vertex C, but it's not given to us. So we cannot assume that this will pass through this C. So it can be like this also, right? So this right bisector is our required line of which we have to find the equation. That's what he wants us to do, the equation of the right bisector, right? And as we have discussed that it's not necessary that this right bisector may pass through C unless it is an equilateral triangle, or it's an isosceles triangle and these two sides are equal, right? Now that is not given to us, so we can't assume that it passes through C. Now let's say that this is point L. L is the midpoint of AB, right? And L is also the point where the right bisector is, this angle is 90 degree, right? So let's find the coordinates of L. L is the midpoint of AB. So this is my x1, y1. This is my x2, y2. So how do I find the coordinates of L? x1 plus x2 by 2. That is -4 plus 6 by 2, and y1 plus y2 by 2, that is 2 plus 4 by 2. So the coordinates of L are 2 by 2, which is 1, and 2 plus 4 is 6, divided by 2 is 3, right? Now we have found the coordinates of L. What else do we require to find the equation of this line? Slope, fine. So if we find the slope of AB, then the product of the slope of AB and this right bisector's slope will be -1, right? So we can easily find the slope of this line, required line. So let's find the slope of AB. So slope of AB will be, A is -4 and 2 and my B is 6 and 4. So this is my x1, y1, this is my x2, y2. So slope of AB is y2 minus y1, that is 4 minus 2, upon x2 minus x1, that is 6 plus 4, which is 2 by 10, which is 1 by 5. So slope of AB is equal to 1 by 5. Therefore, slope of required line will be -5. Right? Because product of the slope of required line and AB is -1. So slope of the required line will be -5. So let's find the equation of the right bisector of AB. Point is 1 and 3, which we have found. Slope also we have found as -5. So equation of right bisector of AB, which divides the AB into two equal parts and it's also perpendicular to line AB, will be y is y minus y1 equal to m times x minus x1. Fine. So this is my x1, this is my y1. So y minus 3 is equal to minus 5 into x minus x1. So y minus 3 is equal to minus 5, x1 is 1. Minus and minus becomes plus. So this becomes, let's shift all of them to this side. So we will get 5x plus y minus 3 minus 5 equal to 0. So finally you got 5x plus y minus 8 equal to 0 as the equation of the right bisector of AB, right? Then he also wants you to calculate the coordinates of the centroid of triangle ABC. Now, tell me, how do we calculate what is a centroid? Centroid is a point where all the medians of the triangle meet. So this is centroid and we denote centroid by G. And how do we calculate? We have already done x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. This is how we calculate the coordinates of a centroid. Now we have this as x1, y1, this as x2, y2, this as x3, y3. So let's calculate the coordinates of centroid. It will be minus 4 plus 6 plus 2 upon 3 and 2 plus 4 minus 2 upon 3. So G will be 6 plus 2 is 8, 8 minus 4 is 4 by 3, 2 and 2 will go 4 by 3. So these are the coordinates of the centroid of this triangle.